Nah. Better. Hello YouTubers. This will be the first of 3 videos. As you know from previous videos, there's 2 weak points in these boards, the speed controller and the BMS. This video will be about getting rid of the BMS. The second video will be about how to charge the board with an off-board charger. And the third video will be about replacing the electronic speed controller. Not the like-for-like replacement, but an upgrade. Anyway, back to this first video. Obviously, before I go any further, a quick warning. If you're not confident with electronics and lithium-ion batteries, don't attempt this. Rather, look at this video as something that I've done for me that I find works. Not as a tutorial telling you what you should do. As I said in the previous video, there are 2 ways of tackling how to get rid of the BMS. One is to remove the BMS module and have the various leads that you connect to attached to the edge of the board. That means having to split them so that some go to the speed controller, some go to the board, and cutting exact holes for the sockets in the board I think could be problematic. Doable, but not as easy as I'd like it to be. So I went for the second route, which was to get rid of the BMS module and modify the board so that the battery becomes an external battery, and you can choose to either plug it into the board or take the leads, put them to one side and charge the battery externally. The benefits of exposing the battery, like I did there, means I can carry 2 battery packs or more, and have one in the board and have 1 or 2 in my backpack, in my rucksack, and when the first battery runs out, slot in a second one, thereby doubling and tripling my range. That alone is worth, I think, getting rid of the BMS. The fact I get rid of one of the 2 major weaknesses at the same time, it's a double whammy really. The specifics of how to get rid of the BMS. Well, before I get onto that, very quickly a side note. You'll know, if you've been watching previous videos, that I've been playing around with the speed controllers on these boards, and this cutting of wires is merely the result of that, so ignore that. Yours will be joined. This isn't, obviously, but just ignore that side of stuff for now. To get rid of that, first 3 things you need to do is undo the 2 screws there, which I've already done, disconnect that, disconnect that. These are the wires from the battery. I can't do that one-handed, so give me a second. So that's the wires removed from the right-hand side of the BMS. From here, you're going to want to get rid of these 2 wires from the charging socket, because you're not going to be using that for charging anymore. So those can come out in their entirety. And after that, you'll want to connect the speed controller directly to the battery, but with a switch in the red wire. So the black one from the speed controller, you will connect to the black one here on the battery, but via a socket, which means the black wire here going to the BMS, that will be removed, and then the BMS can come out in its entirety. I'll show you an after shot so you can see what I'm talking about. That's before, and this is the after shot, as it were. As you can see, it's a much simpler arrangement. You just have the wires coming from the speed controller to here, and this is all unmodified as it was originally. The wire going to the switch is as it was originally. The wire from here I've extended along here to plug into the battery, and you want to keep the switch in the circuit, obviously, so you want this arrangement. And the black wire from that socket I've spliced into here. Everything before that is untouched. Those smaller wires go to the receiver, and from here again it just goes to the battery plug. It's very simple. About the BMS, if it's not working and you've removed it, by all means throw it away. If it is working, don't throw it away. You can use it as an off-board battery charger. In that case, you can remove this charging socket here, so that you'll have it as part of your charging circuit. The next video will explain more detail, but briefly, you'll end up plugging your power supply into this, and that into the battery, and it will charge your battery up. All this stuff is superfluous. You might ask yourself, what's the point of taking it off board if I'm still going to use it as a charger? Well, keep in mind the charging capability of this BMS was never in doubt. It's the fact that it kept trying to limit the current to the motor when using the board as a means of transport. That would make these things blow. So that's the removal of the BMS. Modifying the case. Well, I looked at the original case, long and hard, and I thought, what's the easiest way to modify that? Bearing in mind, my whole ethos for doing this is to target these modifications towards people who don't want to build a board from scratch, but rather want to modify a cheap board as cheaply and easily as possible. So like I said, I was staring at the original case long and hard, and I realised that it lends itself to modification quite easily. 2 cuts is all it takes to make that into this. The first cut obviously is here. Why there? Well, 2 advantages. I want to keep 4 mounting holes for the bolts. 2 won't be enough, and 4 makes it a nice secure arrangement. And the second cut is here, between this raised bolt mount, I guess you'd call it. There's a piece of plastic inside here, that gap, and to remove that is necessary so that the wires here will fit in that gap. Let me show you that in position, make it a bit clearer, like so. The wires fit in there neatly, and that keeps this whole part of the battery compartment whole and intact. Another reason for keeping that is that it's ideal for holding that part of the battery. When this is reversed and mounted back onto the board, the battery just slots into that, which is why you want those wires out of that battery compartment. Anyway, you'll see that in action a bit more clear about later in the video. A couple of side notes. You can see, use some single-sided foam strips and some screw here and here. There's a gap there in the board originally. If you look on this unmodified board, I remove that, you can see there's a gap, and I wanted to fill that in, so I use some screw. Screw is good stuff. It's like blue tack, but you mould it into position, leave it for 24 hours, and then afterwards it's like rubber with a bit of give in it, and yeah, very robust. Why did I do the foam tape and the screw? I want it to increase its splash resistance. I found these boards, when the casing is against a board like so, the fitting along here was far from flush, and water would, or could, drip down here and work its way underneath and into the casing. With the rubber strips, that is pretty much prevented. I'm not saying it's waterproof, far from it, and I still don't recommend riding these boards in the rain, but as a means of increasing its water resistancy, a little bit of effort, and it's done. Same with the screw around the rear hole here for the wire that goes to the motor. To do that, I did that, drew around it with a felt tip pen, placed the tape, then lined that like that, lined up the holes, and then placed that in place. And these, well, it's quite logical really, because they're very near the screw holes, which reflects where it is in the plastic casing. A bit about the screw. It's good stuff, as I said, but to mould it, to get this sharp edge, I put a box here and pushed the screw against it, and I made a channel here with a pen, so that when the wires go along here, they go here, under the depth of the board, and I used a pencil here to get that shape for the large diameter wire from the motor. The other thing you don't need to do, I put some U-shaped rubber trim here. Not necessary, but it does hide the fact that you've taken a saw to this and tidies the whole thing up considerably. So 2 cuts will do this. The foam tape and the rubber trim aren't needed, but for me, I thought why not. So that's the removal of the BMS and how to modify a plastic case. Let me just show you that flipped over. Oh, and before I flip it, if you do use foam tape on the board, the whole height of the case will be increased, which means that ESC won't be flush against the hole in the case. So just put some strips of foam, the same stuff that you used here, and when you turn it over, that will raise the height of the speed controller. And that's it flipped back over. I have to say, what with the foam tape, bit of trim, I think it looks quite professional. Well, professional is probably the wrong word, but it looks passable. Anyway, back to the battery. Again, keeping the idea that I want to modify this with the least amount of effort possible. The 4 original holes and the original bolts that held this part of the case in place are perfect. They positioned pretty much where I'd like them to be, and as I said before, the battery slots into this part of the case. So that's it without the battery, and that's the battery in place. It slots underneath the cover, and these 2 bands hold it very securely in position. This just doesn't move. Getting it in and out is quite a task, which is what you want. You want it held firmly in position. The washers. You want something wide enough to cover the width of the elastic, but not so wide it encroaches on the space of the battery. The end result will be very snug, which is what you want. You want 2 per side. Because the board curves a bit, to clamp down on the board with a flat washer is less than ideal. So you want a flat washer under that and a flat washer on top, and you want to clamp that strap between the 2 washers securely. The end of the elastic, I got a lighter and melted any frayed or plastic remnants to seal it all up and help prevent any fraying. And I put some shrink wrap on the ends of each strap. That might help with the fraying. I really did that more for cosmetic reasons. So that's the bands in place. If you find that after you slide the battery under the plastic here, that it doesn't come up under the band here enough, that plastic moulding here, the bottom of the battery, that bit it rests against, if you put some foam tape on that, so you therefore raise it a little bit, the whole battery will be raised up the board and it's forced to go under the elastic strap there, and therefore you get a very snug fit. Time for another warning, I think. These are lithium-ion batteries and have inherent risks. If you're not knowledgeable about these lithium batteries, don't do this. keep in mind what I'm telling you here isn't a tutorial, I'm telling you what worked for me. The first thing to note, that the battery is now exposed and can be punctured. If you don't know, puncturing a lithium ion battery is a bad idea. It can cause an explosion. So this is exposed, and ideally on boards that are released via manufacturer, they're always covered. Having said that, people who make modifications to boards run these things exposed fairly regularly. I'll leave a link in the description under the video about a guy who boosted the range in his boosted board by strapping or velcroing batteries under his board, and the batteries were much like this. They were exposed. Different type of battery, with different shape anyway, but same sort of thing, exposed. And he runs his in dry weather successfully for quite some time now. Another thing to keep in mind about lithium ion batteries, you don't want to get them wet. So what I did, I got some of this waterproof tape. It's strong stuff and very sticky, and I went over the battery. This one here had no shrink wrap on it, so I went over the whole thing. This one had shrink wrap on it, but the ends were exposed, so I went over the ends of the battery. Another thing to keep in mind, taking this battery in and out. I wish I could show you, but it's very difficult to do it one-handed. Well, it's impossible to do it one-handed, but to do it, you have to slide the whole battery up here as much as possible to bring that bottom part up beyond the edge of the plastic casing. When you've done that, you then, whilst holding this up, lift it up above the plastic casing and slide the whole thing out. A good thing that's quite shallow. Doing that will increase the risk of the battery trying to flex, particularly here at the join. So using that tape, I reinforce that whole join on both batteries. You can't see it so well on this one, and that really increases its stiffness. Yeah. Ideally, if I had time, and I was rushing a bit to get this video out, but I would like to have a piece of perspex top and bottom sandwiching these batteries. That will stop this from flexing at all and increase its resistance to being punctured. I might do that. At the moment though, this works well enough for me. If I did put perspex on there, I'd have to account for the narrowness of the plastic casing here, so I'll probably have plastic sheeting on top of the battery and have it finish here, so it butts up against the plastic casing. And lastly, the lead to the battery. I extended it from under the casing using the same gauge wire that the motor uses. You don't want to go any thinner, and you want to butt it up against the trucks as much as possible. You don't want that away, because if you do, you'll make the battery experience increased flex as you push it that way to remove it. The further that way this is, the less flex the battery has to go through to be removed. I don't know if you remember, but to remove the battery it has to go that way first, and then as that's released from underneath here, it then goes that way. So yeah, to get that up against the trucks as much as possible. This bit here is of note. You want it to not have too much flex. You don't want this wire to drag down and possibly hit the ground, but you want enough flex so that you can mount the battery or this way or that way, or we can do the other battery. Account for the differences in length of these wires. They're not the same. This and this wire are different lengths, so you want a bit of flexibility to account for different lengths of wire. And lastly, I want to increase the water resistance on these metal tabs on the balance lead. People leave these exposed, and as I mentioned before, some people on forums have said getting these things wet isn't a problem. This particular bit here, I don't like the idea of water splashing across several contacts and causing a short circuit. So what I did is I took an old socket and did the following, and I attached it with some elastic, and that should increase its resistance to water and splashes. Not particularly pretty, but that should do the trick. The braiding, you don't have to do that. I put it on there to increase marginally its resistance to being cut or whatever, but mainly for its cosmetic purpose. It does make those red and black wires look a bit smarter. As I said before, this is not meant to be used in the rain, but I have taken precautions to make it somewhat water resistant. But really, this could be done without any of that. All you need to do is take the BMS out of the circuit here, which is easily done, and I showed you earlier in the video. Do 2 cuts to the plastic, one to get rid of this part of it, and one to allow for the cable to run into the plastic casing. Mount 2 straps with the existing holes and some washers, extend the lead here, and you've done it. So there you have it, one of 2 weak points, the BMS blowing under acceleration, has been solved. It's been taken off board completely, and the bonus is you can use a second battery and take the first one out and slide the second one in place and double the range. Another advantage is this is now a suitable platform for further modifications. The fact that this casing has been removed and you've got this large expanse of space, you can quite easily mount 2 batteries in parallel. You'd have to have spaces here so it doesn't flex against this part of the board, and there's inherent risk with the battery being nearer to the ground, but that's possible. The other advantage is that you can take this battery off completely and use third-party batteries. Turnigy do a range of high-capacity batteries, and using a different way of mounting them, that industrial strength velcro, which I mentioned earlier in the video, is a good way of doing it. You can have other batteries here, and the high-capacity ones will increase the range considerably. So that's the first modification done. And now that you've removed the BMS, how on earth are you meant to charge the thing? Well, see the next video for that. Until next time, bye for now.